So 6.2 goes over radicals and rational exponents. Your rational exponents are just powers that are fractions. Those fractions represent a root that you are taking. That root is called the radical. That number that's on the outside of that radical house is called your index. So it tells you how many times you need the same number to multiply by in order to get the number underneath the radical. So if we look at the first example, it tells us to find the indicated nth root or roots of a. So a is going to be the number underneath the radical. The number that's n is your index. So it's going to tell you how many times you need the same number in order to equal the number underneath the radical. With these, if n is an odd number, then one root is what you're going to have. If n is even, then your a has to be greater than 0. So if your n, your index, is an odd number, then you can have a negative underneath that radical sign. However, if it's not and is an even number, you have to have a positive underneath the radical sign. If you don't, then it's no solution. The nth root of 0 is always 0. The nth root of 1 is always 1. You have to be careful, though, because if you have a negative 1 underneath that radical, if the index is even, it's going to be a positive 1. If the index is odd, then it's going to be a negative 1. So if we look at example A, we're given an n of 3 and an a of negative 27. So this just means that we're taking the cube root of negative 27. So from here, what I like to do is I like to circle my index to tell me how many of the same number I need to have in order to equal that number underneath there. I do have a negative, so I'm going to circle that as well, so that way I remind myself that my answer is going to be negative also. So from here, the way that I find this, if I don't know it off the top of my head, I find the prime factorization of the number underneath the radical. I know that 27 is 3 times 9, and 9 is 3 times 3. I told myself that I have that negative. My answer has to be negative. So I'm going to take the opposite of the cube root of 3 times 3 times 3. My index is 3, which means I need a group of 3 3s in order to pull 1 out. I have 3 3s, so that represents as a 3, and I turn that into a negative. That negative 3 is the cube root of negative 27. For example B, you have an n of 4 and an a of 16. This just means you're taking the fourth root of 16. So the first thing I'm going to do, my number underneath is the 16. My index is the 4. Whatever I find the prime factorization of that 16, I'm going to have 4 of the same numbers in order to pull one of those numbers out to get rid of that radical. So first I'm going to find the prime factorization of that 16. I have, let's say, 4 and 4. The 4 simplifies to be 2 and 2. So I can rewrite this as the fourth root of the prime factorization of 16, which is 2 times 2 times 2 times 2. Again, our index is that 4. It tells us that in order to simplify this and get rid of that radical, I need to have 4 of the same number in order to reduce that radical or get rid of that radical. So look underneath that radical. I rewrote that 16 using the prime factorization of it. I do have 4 2's. So because I have 4 2's, that fourth root can cancel out, and I just have to write one of those 2's down. I didn't have any signs with this, so that 2 is just my answer. For example C, we have an n that's equal to 3 and an a that's equal to negative 125. So this is telling us to take the cube root of negative 125. So the first thing I realize here is I have a negative underneath that radical sign. Because I have a negative underneath the radical sign, I need to check the index. Is the index even or odd? The 3 is an odd number, so the negative underneath is okay. I'm going to circle it To remind myself, my answer has to have that negative. I can also rewrite this as a negative cube root of 125. So from here, I'm going to take the prime factorization of that 125. The 125 is 5 times 25. The 25 is 5 times 5. All of those 5s are prime numbers, so my prime factorization of 125 is 5 times 5 times 5. So I'm going to rewrite this as the opposite of the cube root of 5 times 5 times 5. Now that my radical has the prime factorization of that 125 underneath it, I'm going to look at my index. My index is 3. I'm going to ask myself, do I have 3 of the same number underneath the radical so I can eliminate the radical? My index is 3. I have 3 5s. So the cube root goes away, and I just write one of those 5s down. I apply the negative, and I'm all done. For example D, we have n is equal to 6, a is equal to 64. So this means that we are taking the 6th root of 64. I don't have any signs here, so I'm okay to keep going. I'm going to find the prime factorization of the number underneath the radical, which is 64. I know 64 is 8 times 8. The 8 is 4 times 2, and the 4 is 2 times 2. Once again, the 8 is 2 times 4, the 4 is 2 times 2. So my prime numbers here, I'm going to rewrite them as the 6th root of 2 times 2 times 2 times 2 times 2 times 2. My index tells me in order for me to get rid of my radical, I need 6 of the same numbers. Do I have 6 of the same numbers underneath that radical once I rewrote that 64 as its prime factorization? I have 1, 2, 3, 4, 5, 6 2's, so this 6th root gets canceled out, and I rewrite one of those 2's. So the 6th root of 64 is just 2. If we look at example 2, we're just evaluating each of these expressions. For A, we have the cube root of negative 8. We have a negative underneath the radical. Our index is 3, which is an odd number. So I'm going to keep that negative out front and just take the cube root of 8. I need to find the prime factorization of that 8. The 8 is 2 times 4. The 4 is 2 times 2. So I can rewrite this as the opposite of the cube root of 2 times 2 times 2. Our index is 3. So I need 3 of the same number in order to cancel out that radical. Do I have 3 2's? I have 1, 2, 3. Yes, I do. So I can cancel out that radical and just rewrite one of those 2's with that negative in front of it, and that is my answer. For example B, we have the opposite of the cube root of 8. So once again, I'm going to take the prime factorization of that 8. We just found it, so that's just taking the opposite of the cube root of 2 times 2 times 2. I'm looking for 3 of the same number. I have 3 2's. So I can pair those up, get rid of that radical, apply the negative to it, and I just have negative 2 for our solution. For example C, we have 16th to the power of 1/4. These fractions as our exponents represent the radical, or the index that we're taking. The one that's up top here is going to be the power that stays with the number that it's attached to. The denominator of this 4 is your index. So this is telling us to take the 4th root of 16 to the 1st power. which is just the 4th root of 16. I take the prime factorization of that 16. I have 4 times 4. The 4 is 2 times 2. So this is the same thing as the 4th root of 2 times 2 times 2 times 2. I'm looking for 4 of the same number. I have 1, 2, 3, 4 2's, so I can eliminate the radical, group the 2's up, pull 1 out to represent all 4 of those 2's, and that is my solution. For example D, we have negative 16 raised to the power of 1/4. So again, the 1 is our power, the 4 is our index. So this is telling us to take the 4th root of negative 16. Now, we have a negative underneath that radical sign. The index is even. Can we do that? No. In order for us to do the radical of anything that's a negative, our index has to be odd. So because we have a negative underneath there and our index is even, this is automatically no solution. For example E, we have the cube root of negative 125. So this is just telling us we have an odd index, a negative underneath, so that's okay. I'm going to pull that negative out and just apply it to whatever my answer is. So I'm still just going to take the cube root of 125. That 125, if I find the prime factorization of it, 5 goes into it 25 times, and 25 is 5 times 5. So this is giving me the opposite of the cube root of 5 times 5 times 5. My index is 3. I need 3 of the same number underneath that radical in order to eliminate my radical. So I have 1, 2, 3 5's. I'm going to group them up, get rid of that radical, and rewrite it as just the 5 to represent what's inside. I apply that negative, and I have my answer. If we look at the next part of our notes, we're just evaluating expressions with these rational exponents. So we just have to rewrite them first, and then simplify. So if we look at example A, we have 16 to the power of 3/4. We said that the 3, that's the numerator, is our power, and the denominator of that 4 is our index. So I'm going to rewrite this as the 4th root of 16 raised to the 3rd power. Now you can write this one of two ways. You can write it this way, or it can be the 4th root of 16 to the 3rd power with the 3 underneath the radical. I don't like doing it that way because that just means I have to take that 16 and multiply it by itself 3 times, and I'm going to be working with a much larger number that I don't want to work with. So I choose to do it the first way that I wrote it, simply because to me, I find it easier. So I'm going to find the prime factorization of 16. That 16 is 4 times 4. The 4 is 2 times 2. So this is giving us really the 4th root of 2 times 2 times 2 times 2, all raised to the 3rd power. So my index is 4. I need 4 of the same number in order to get rid of that radical. So 1, 2, 3, 4. I can get rid of that radical, rewrite one of those 2's, so I just have 2 to the 3rd power. 2 to the 3rd power is 8, so our answer is 8. For B, we have 27 raised to the 4/3. So that 4/3, I have to find my index and my power from it. Remember, numerator, power, denominator, index. So we can rewrite this as the cube root of 27 raised to the 4th power. Again, I choose to do it this way just because I find it simpler. I don't want to multiply the 27 by itself 4 times and then find the cube root of whatever that number is. So if I was to do that, that 27 to the 4th power is 331,776. So I'd be taking the cube root of 331,776. I don't want to do that. That's way too much work for me. So I'm going to keep it this way and work with it with a little bit simpler terms. So we are taking the cube root of 27 first, then whatever we get from that, we're going to raise it to the 4th power. I'm going to find the prime factorization of 27. We have 3 and 9. The 9 is 3 and 3. I have all prime numbers, so I have the cube root of 3 times 3 times 3 raised to the 4th power. My index tells me I need 3 of the same numbers. 1, 2, 3 3s. I can get rid of that radical. I can just rewrite one of those 3's to represent it. And I'm going to raise that 3 to the 4th power. So I'm going to do 3 times 3 times 3 times 3. 3 times 3 is 9. 9 times 9 is 81. For example C, we have negative 64 raised to the 2/3 power. So that 2 is going to be our power. That 3 is our index. So this is telling us to take the cube root of negative 64 and raise it to the 2nd power. I'm going to first pull out that negative because I'm okay with that radical. I have an odd, I'm okay with the index. I have an odd index, so I can just take that negative out and find the cube root of 64. And then once I do that, I can square it. So I'm going to take the prime factorization of 64. We have 8 and 8. The 8 is 4 and 2. 4 is 2 and 2. So this is giving us the the negative cube root of 2 times 2 times 2 times 2 times 2 times 2. And we're going to take this and square it once we get our answer. So our index is 3, which means we need 3 of the same number in order to pull one of them out. I have 1, 2, 3 2's, so these pair up. I'm going to pull one of those 2's out. I have another set of 1, 2, 3 2's, so I pull another 2 out. I'm going to multiply these 3 and then apply the negative to it. The 2 times 2 gives us 4. I apply that negative. I get negative 4 squared, which gives us 16. So anytime you have more than one number that you can pull out, like in this case, you would just multiply those numbers. For example, D, we have 9 to the power of 5 over 2. That 5 is going to be your power. The 2 is your index. So this is telling us to take the square root of 9 raised to the 5th power. From here, we take the second root of 9, which is 3 times 3. So that's the square root of 3 times 3, all raised to the 5th power. The 3 times 3 gives us our two numbers that we need that are the same. So that's 3 to the 5th power. This is the same as 3 times 3 times 3 times 3 times 3. We know that 3 times 3 is 9. So 9 times 9 is 81 times 3 gives us 243. For example, E, we have 256 raised to the 3/4 power. So that 3 is our power. That's going to stay. That 4 is our index. So this is going to be written as the 4th root of 256, all raised to the 3rd power. I'm going to find the prime factorization of that 256 first. So I know that 256 can be divided by 4. That's 64. The 64 can be divided by 8. That's 8. The 8 is 4 and 2. The other 8 is 2 and 4. So this is 2 times 2. This is 2 times 2. This is 2 times 2. So I have 1, 2, 3, 4, 5, 6, 7, 8 2's. So I have the 4th root of 2 times 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All raised to the 3rd power. So I need 4 of the same number. 1, 2, 3, 4. I have 4 2's here. I'm going to pull one of those out. I have another 1, 2, 3, 4 2's. I'm going to pull another 2 out, and I'm going to multiply these two. The 2 times 2 is 4. I then raise it to the 3rd power to give me 4 times 4 times 4, which is 16 times 4, and that is 64. For our last example, it tells us that the radius r of a sphere is given by the equation r is equal to 3 times v over 4 pi, all raised to the 1/3 power, where v is the volume of the sphere. Find the radius of the beach ball to the nearest foot. Use 3.14 for pi. It tells us that the volume of this ball is 113 cubic feet. So we're going to take that equation that r is equal to 3 times v over 4 pi raised to the 1/3 power. And we're going to take what v is, which is 113, and pi, which is telling us 3.14. We're just going to plug these values in and solve for r. So r is equal to 3 times 113 all over 4 times 3.14 raised to the 1/3 power. Now we can rewrite this as the cube root of 3 times 113, which is 339, over 3 times, no, it is 3 times 3.4 times 3.14, which is 12.56. So from here, I'm not going to require you to use a calculator to do this. You could leave it just like this if you cannot simplify it any further. That 339 you couldn't take the cube root of, so you, again, would just leave it like this. If I was requiring you to take a calculator and simplify it further, I would expect you to do that. However, again, that's not what I'm letting you do, or that's not what I'm allowing you to do. So you would not go any further from this.